Quick introduction for anyone who doesn't know me. I'm a principal video engineer at Vimeo. I work on a lot of open source software like FFmpeg, FMS2, etc., etc. I sit on the Videoland nonprofit board, and of course, most people know me from Twitter, where I only post the most quality content. Usually I'm this guy, but, we're locked down right now, so I'm this guy right now. Backwards compatibility, everybody's favorite subject. We'll be dealing with interlaced video long after we're all dead. But apparently we'll also be dealing with progressive MP4 long after we're all dead as well. This is 2021 though, and we do adaptive bitrate streaming. So everything's stored as fragmented MP4s, particularly self-initializing fragmented MP4s, which means it only has one index range that says where all the different segments are inside the front of the file. And audio and video are separate. And this means CDNs can just make a range request within this file to get any segment they need. This is, it's easier logic in app, easier caching for the CDNs. Some companies, of course, to ease this, they transcode directly to progressive MP4 and then they segment at the edge. But this is either expensive because you're paying someone else to segment it for you, or it's expensive in a different way because you have to maintain, build, and run a CDN edge segmenter and put all your traffic through it. I guess some people probably encode directly to MPEG TS and store that, but I'm not going to acknowledge these people exist because they're all horrible people. But of course, you can't just ignore 10 plus years of backwards compatibility. Like, there's a lot of stuff that only can consume progressive MP4s, and maybe your company made a decision 10 years ago and said people who pay us a bunch of money can get direct links to their MP4s so they can embed them in a video tag, embed them in their app, etc., etc. And also maybe you have 10 years of hard-coded logic around the use of progressive MP4s in your web app. So there are a number of options you can use to support both adaptive bitrate streaming and progressive MP4 fallback. The obvious one is don't store it as fragmented MP4. Segment it at the CDN edge, as previously mentioned, is very expensive. The engineer's decision, which you could just completely remove support for it. Not a lot of work, just remove it all, tell everyone to bugger off. But that's pretty much the worst option for everyone else. It'll anger your product, anger your marketing, anger your most high-paying users, and it'll anger the users who are on an iPhone from 10 years ago. One option, which I believe YouTube does, is transcode one single rendition, like 720p progressive, and just store that whenever everyone needs it. It's not a lot of work, but depending on your scale, it's a lot of storage for a rendition of a video that's almost never used. Like, very, very few things need to fall back anymore in the grand scheme of things. And of course, people still be angry because, you took away their 240p download or their 4K download. They can only download 720p now. And obviously, the last option is write a very clever service that makes fragmented MP4s with separate video and audio just appear to be progressive to broad browsers. This is obviously the most engineering work, but the service, the amount of data flowing through this should be pretty low and should be a lot cheaper than running a CDN edge segmenter, for all other traffic. So obviously we chose the hard one. It needed to be several things for it to be viable. So you have to transparently expose a set of fragmented MP4s, so one video, one audio track, which are separate files, as a progressive MP4. So proxy it, it'll just magically appear like that going through this service. It has to support range requests because, when a browser watches an MP4, it needs to do range requests. It needs to get the packets and everything from the MDAT box. And it's also important for CDN cacheability because if you don't support range requests, for example, on Akamai, you have a limit to the file size. And they also won't properly support if a user's downloading and the connection drops. They'll just throw the whole thing away. And obviously this needs to be performant. You can't be, reparsing the source file on every different range request. That would be dumb. So there are a lot of MP4 libraries, a lot of muxers, a lot of demuxers, but essentially none of these are suitable for this problem. They're all generic. They're all assuming you want to just either remux on the disk, or that you want to mux to a different format, or you want to import some format, and they just aren't suitable for streaming or doing any of this up front, because for example, most muxers will read the entire file, then make the move box, then move that to the front, which is, if you need this stuff up front, it's not going to work. In our case, all the known input is good. We make these files, and if the input is bad, we want to hard fail it. So anyway, I wrote one. Meet Artax. For anyone who's not intimately familiar with our internal transcoding infrastructure, they're all named after very dated movies. In particular, our chunk transcoder is named Falkor from the Never-Ending Stories, so it seemed cromulent to name this service Artax, the horse that dies in the swamp of sadness. A quick high-level overview of what an MP4 looks like internally. We'll go a little deeper in that later on, but at a very high level, it's a set of boxes which are just structures, the internal structures of how an MP4 and how a MOV file works. They all start with an ftip box, which just has a bunch of strings in it that says what kind of file, what kind of MP4 this is. It has a move box that has all the info about what kind of streams are in there. And here's where they deviate a little. In a fragmented MP4, there is a SIDX box, which has all the offsets and all the start times for all the video segments. So every 3 seconds or every 6 seconds or whatever segment size you're using. And for each of those segments, it has a move box, which has sub boxes, which have all the packet sizes, timestamps, etc. for those packets in that segment, and the MDAT box, which has that has all the packets for that segment. Whereas a progressive MP4, it just has a move which contains all the info about all the samples and all the timestamps, and then the MDAT with all the packets in it. But it's not that simple. If you dig down a little deeper to the sub boxes, there's a lot of crap in there. Not all of it super relevant to anything. So part of the reason probably why no one's written this sort of thing before is it's super tedious. You have to parse and write all of these this large amount of different data and boxes in the MP4. So we need a couple different strategies for generating the different boxes of the output progressive MP4, since we want to generate the move at the front of the MP4 rather than the end. So we want to parse and generate it entirely up front, and the way we do that is by first parsing the move and SIDX boxes of the two input files, which will get us all the offsets for all the segments in the move boxes. And then, we might have, 1,000 of those. And rather than sequentially parsing through that file over a network, which is really slow, we can use a thread pool, or in our case, a Go routine pool that just says, here's 100 threads, do 100 parallel requests to get all the info from these move boxes and fill it out in this struct. And after parsing all these, you can basically construct everything you need to know up front about the move. You can know the whole size of the move atom, the whole size of the MDAT box, the full file size, all the timestamps, all keyframes, and all the offsets into the MDAT box where your packets are going to be up front. You can just generate the move once, write it out. No moving, no writing at the end, no parsing the whole file with all the packets and remuxing it, for example, libav format would end up doing. And this means you can set the content length, and it means the little trickery, you can support range requests into this file. And of course, we want to cache this because doing this is expensive, and we only want to do it once. And the MDAT box, which is where all the packets are stored, is a little trickier. We do have all the packet sizes and the positions of those packets in the source files. But we need to properly interleave these audio and video packets. And we chose 500 milliseconds interleaving here. And one important thing to not overlook here is that the interleaving, that is where you are in the sequence of packets, is state. It has to be consistent regardless of which range request. So if you request byte 30,000 to 40,000, you need to know exactly where in the interleaving sequence you are in order to fulfill that range request. So if you're like 4 packets plus 4 bytes into the set of 13 video packets, followed by 24 audio packets, you need to know that so you can ideally only read what you need from the source file, because you don't want to be reading more than you need to from the source file because we're over network. And you need to know this exactly. And you want to use persistent HTTP connections for reading the source packets, because a lot of range requests are very slow, and things like Google Cloud Storage have very, very high tail latency. And yes, you'll take a minor hit because you are basically also reading the move boxes and stuff between them, but those are like on the order of a couple of bytes, and it's worth wasting that bandwidth just to keep it persistent so you don't hit GCS tail latency. And depending on the size of your input, a prefetch is also useful here. So you can get stuff started like immediately. And now for probably the hardest thing, which is range request support. The ftip and the move boxes are easy because those are calculated and cached already. They're a byte buffer. It's very easy. Just grab these range bytes from this buffer. You do need to be a little careful at the edge of these, what's cached and what's not cached, so you don't accidentally have a one byte off error at this boundary. The MDAT box is much trickier because you need to calculate where in the 2 source MDAT boxes you get these packets. So that is which MDAT of, like, say, the 1,000 MDATs in that file you need to seek to, well, not seek to, but start reading from, how many packets into that MDAT you start reading from, and then how many bytes to skip in that first packet and how many bytes to lop off in the end packet. And you need to know as previously mentioned, the exact position and state of the packet interleaving. And this is mostly just a ton of bookkeeping. But the gist of it is, if you know all the source sample sizes, you can basically just start interleaving from the beginning or from a known good state and regenerate that state on each request. Uses a little CPU, but it's fairly easy, I would think. It's just a lot of bookkeeping. All right, so now I'm going to do a demo. So like you can see that this is a thing that I actually wrote and exists and it works and it's all written in Go and it doesn't use FFmpeg. Enjoy. Okay, so demo time. You can see I'm doing capture in the most professional way possible. But anyway, let's take a look at what we got here. We have two source dash files, which will be served over HTTP. I just have them here for convenience of showing you the box structure because they're local. And the world's crappiest server that just takes byte requests and sends it off to the packager, or the reverse packager, I guess you'd call it. So yeah, if we take a look at the 240p file here, which is just kind of what I had on hand, take a look at the boxes in it, and you can see, it's a self-initializing dash file, fragmented before, got all a million MDATs, a million moves, and same for the audio. Ooh, what did I typo? Yeah, double MB4. Yeah, same thing. All of those, a million moves. Probed, nothing special. Yeah, and if you look at the crappy server, nothing, not linked to anything, just plain old Go. The remuxer /packager, Same, not linked to anything. Just go. If you look at what this actually is, it's literally just like the world's crappiest HTTP server that says, you know, get a range request, ask for it from this CLI tool, because I was too lazy to use a Go package right now. Yeah, so nothing magical going on here. So yeah, let's run that and take a look. This is over network, by the way. This isn't France. I should turn that off. Yeah, so, you know, it's exposed as a single progressive MP4, range requests work, everything. You can seek around. Performance is pretty good. I promise that's not because it's 240p. See, audio's working. And if we look at the URL in FFFprobe, you can see it's remuxed by Artax. And if we take a look at the box structure, yep, it is nothing special. Just move some tracks, single MDAT. Yep, nothing special. So it works as intended. Cool. Now back to previous. And with that, we'll go back to Phil, and you guys can ask me any questions you want about it, or tell me what a disgusting service this is, or anything of the sort.